Picture your car's engine, a chamber of controlled chaos where thousands of tiny explosions happen every minute. Each piston compresses a volatile mix of air and fuel, all waiting for one thing, a spark. That spark, delivered with split-second precision, is what unleashes the engine's power. The unsung hero behind this? The spark plug. It's the match that lights the fire, again and again, in a brutal environment of heat and pressure. If the spark comes too early or too late, your engine loses power or even gets damaged. The spark plug channels a high-voltage pulse, sometimes over 40,000 volts, across a tiny gap, creating a plasma hotter than the sun's surface. This ignites the fuel-air mixture, driving the piston and turning the crankshaft. It's a tiny lightning storm happening under your hood, millions of times over the life of your car. Most people never think about spark plugs until their car won't start. But without them, the world would be a much quieter, slower place. The spark plug is the heart of the gasoline engine, a marvel of engineering and endurance. Its story is one of relentless innovation, a story worth telling. The spark plug story starts in 1859 with Étienne Lenoir, who needed a way to ignite his early engine. His crude jumping spark system was unreliable, but it proved electric ignition was the future. Nikola Tesla took things further in 1898, patenting a high-voltage ignition system that laid the groundwork for modern technology. Meanwhile, Frederick Sims and Robert Bosch teamed up to create the first commercially viable high-voltage magneto and spark plug combo. Bosch's design with better insulators and electrodes became the gold standard. Inventors like Carl Benz and Albert Champion also joined the race, each improving reliability and durability. The challenge was always the same: create a spark in a hostile environment. They experimented with insulators, electrode shapes, and sealing methods. It was a global race to build a better fire starter. Their breakthroughs ignited the automotive revolution. The spark plug became a symbol of ingenuity, powering the world's first cars. Every improvement brought us closer to the reliable engines we depend on today. The early years were a whirlwind of invention and competition. Their collective genius changed transportation forever. At first glance, a spark plug looks simple, a ceramic bolt with a metal tip, but inside it's a marvel of engineering, designed to deliver a high-voltage jolt at precisely the right moment. Electricity enters at the terminal nut, travels down the center electrode, and is insulated by a tough ceramic shell. The insulator must withstand extreme heat, voltage, and vibration without cracking. The ribs on the outside prevent voltage from arcing down the plug's exterior. At the tip, the electricity faces a tiny gap between the center and ground electrodes. The metal shell grounds the circuit, and the voltage leaps the gap, creating the spark. The gap's size is critical, just a few hundredths of an inch. Gaskets or tapered seats seal the plug against combustion pressure and help transfer heat. Every part, from the terminal to the gasket, is refined for durability and performance. The spark plug must survive millions of cycles in brutal conditions. It's a masterpiece of simple, effective design. Without it, your engine is just a silent block of metal. Early spark plugs were fragile and unreliable. Porcelain insulators cracked from thermal shock. Mica fouled with oil and carbon. Drivers carried spare plugs and cleaned them constantly. The challenge: find an insulator that was strong, electrically resistant, and could handle heat. The breakthrough came in the 1930s with alumina ceramic, stronger, cleaner, and more durable. This material allowed plugs to run hotter, burning off deposits and staying clean. Self-cleaning plugs became possible, transforming reliability. Electrodes also evolved, from eroding nickel alloys to tougher, longer-lasting materials. Engineers experimented with alloys, fighting erosion and corrosion. Every improvement meant longer life and better performance. The right materials turned the spark plug from a weak link into a durable workhorse. Material science made the modern engine possible. The heat range of a spark plug isn't about spark intensity, it's about how well it sheds heat. Too hot, and the tip glows, causing pre-ignition and engine damage. Too cold and deposits build up, causing misfires and poor performance. The insulator nose's length controls heat transfer, long for hot plugs, short for cold. The right heat range keeps the plug in a Goldilocks zone, hot enough to stay clean, cool enough to avoid pre-ignition. High-performance engines need cold plugs. Commuter cars need hotter ones. Using the wrong heat range can ruin an engine. It's a delicate balance, critical for engine health. Engineers fine-tune this for every engine design. The right plug keeps your engine running strong and clean. For decades, spark plugs barely changed. One center, one ground electrode. But as engines advanced, so did spark plug design. Multi-ground electrode plugs added redundancy, distributing wear and extending life. Surface discharge plugs let the spark travel along the insulator, improving combustion and resisting fouling. These are great for engines with oil issues or rich mixtures, like Mazda's rotary engines. V-groove and U-groove designs expose more of the flame front, boosting performance. Every tweak aimed to make a more reliable spark and longer-lasting plug. The goal: better combustion, fewer misfires, and less maintenance. Spark plug design became a field of constant innovation. Each new idea pushed engines to new heights. The humble plug kept evolving to meet the demands of modern engines. For most of history, spark plugs relied on distributors and long wires, systems prone to wear and energy loss. The 1990s brought coil-on-plug, COP ignition. Each plug gets its own coil, right on top. This shortens the path for electricity, delivering a hotter, more precise spark. The engine's computer can now control each cylinder's timing with pinpoint accuracy. COP systems are more reliable and efficient, key to modern engine performance. At the same time, spark plug tips evolved from nickel to precious metals. Platinum and iridium resist erosion and heat, lasting over 100,000 miles. Fine wire electrodes need less voltage and improve combustion. Double platinum and iridium plugs set new standards for durability. These advances mean fewer misfires, better fuel economy, and longer service intervals. The combination of COP and precious metals revolutionized ignition. Today's spark plugs are tougher and smarter than ever. What if spark plugs could talk to the engine's computer? That's the idea behind Ionic sensing technology. After firing, a small voltage is applied across the gap. The resulting ion current reveals what happened during combustion. The computer can detect misfires, knock, and even the air-fuel ratio in real time. The spark plug becomes a sensor, not just an actuator. This allows for instant adjustments, preventing engine damage and optimizing performance. No need for separate knock sensors. The plug does it all. Manufacturers like Saab and BMW already use this tech. It's a leap forward in engine management and efficiency. The spark plug is now a vital part of a closed-loop control system. With electric vehicles on the rise, it seems like the spark plug's days are numbered. EVs don't need sparks, no explosions, no pistons, no plugs. But the transition to all-electric will take decades. Millions of gasoline cars and hybrids will still need spark plugs for years to come. Hybrids in particular demand even more from spark plugs: reliable ignition under tough, variable conditions. Internal combustion isn't disappearing from trucks, generators, or industry anytime soon. New fuels like hydrogen and biofuels will need advanced spark plug tech. The spark plug story isn't over, it's evolving. It remains a symbol of ingenuity and innovation. Lessons learned from a century of spark plug development will shape future engineering. The spark plug ignited the modern world. Its legacy will burn bright for generations. Even in an electric age, its impact endures.